It's really easy to set up autoscaling on your Google Cloud Managed instance groups. The configuration options offer lots of flexibility to help fit your application's needs. Let's dive a little deeper into autoscaling and check out 3 things that will help you set up effective autoscaling on your instance groups. To implement more effective autoscaling, it's helpful to understand how it generally works. The autoscaler monitors your instance group and offers a size recommendation. That's a calculated number of VMs needed to serve the peak load over the last 10 minutes. These 10 minutes are referred to as the stabilization period. This stabilization period is 10 minutes, so the autoscaler can ensure that usage info that it uses to scale in and out is stable, and that helps prevent the autoscaler from adding and removing machines at an excessive rate. When scaling back down, it's able to determine the smaller group size will be able to support the peak load so that it can safely remove instances. When autoscaling is turned on, the number of VMs it scales your instance group up and down to will be limited by the minimum and maximum number of VMs that you specify. When scaling in, the number of VMs it can remove is also limited by the scale-in controls, if specified. If you configure autoscaling and leave it turned off, it still calculates recommendations, so you can see what the autoscaler would do if it's turned on, without having to spin up additional machines in the process. This way, you can see the effects it'll have before actually committing to them. So now that you know a little bit about how it works, here are 3 things to consider when designing your autoscaling configuration. Thing number 1, the machine type. Okay, so technically this isn't part of the autoscale configuration. You actually indicate the machine type on the instance template associated with your instance group. But that's why it's so important for autoscaling. A new instance of that type will be provisioned when the instance group is scaled up. You might be thinking, well, yeah, of course. But this is when knowing your application is key. For example, if you know that your application that you're running on your instance group needs 2 virtual CPUs, then E2 standard 2 has got you covered. But if you also know that the same application doesn't need much memory, then E2 high CPU 2 offers the same number of virtual CPUs with less memory. Choosing that one means that every time you scale your instance group out, you're not scaling out or paying for resources that you won't be using. Okay, thing 2, the cooldown period. For effective autoscaling, you want to make sure you specify an accurate cooldown period. The cooldown period is the initialization time, the amount of time it takes for your application to initialize after the host VM has been provisioned. You want to be sure that you have an accurate one specified. If you specify a cooldown period that's too long, then your autoscaler will miss out on that utilization data and potentially underestimate the required size of your group. On the flip side, if you specify a cooldown period that's shorter than it takes for your application to be ready, then it's possible for the autoscaler to get inaccurate utilization data because in some cases, CPU utilization while things are getting up and running is higher and isn't a reflection of normal use. Finally, there's thing 3, scaling controls. The ability for your managed instance group to scale is a big win for reducing costs. But you don't want to take a hit in performance when you do that. Scaling controls let you slow things down by establishing a rate that the autoscaler will scale down at. This way, you'll be able to avoid dramatic drops in group size. Remember that cooldown period I just mentioned before? If your cooldown period is on the long side, by using scaling controls, you'll have the added benefit when there's a sudden spike in demand. You'll already have machines available and you can avoid delays caused by long initializations. Setting up the right scaling controls, just like choosing the right machine and accurate cooldown period, all comes down to knowing your application, its requirements, and expected load and behavior. Let's take a look at this managed instance group that I've set up on a Google Cloud project. Here's a few things about my configuration. I've set my minimum instances to 2 and my maximum to 100. When I set this up, I wasn't sure about cooldown period, so I left it at the default value of 60 seconds. I wasn't sure about scaling controls, so I left that disabled. The instance template uses an E2 standard 2. Let's see how we can make changes to this configuration. Let's edit my managed instance group called Web App Instance Group and check out the autoscale settings. We've got a regional managed instance group, so right off the bat, I want to take advantage of high availability by making sure that I've got at least 1 instance in each of my zones. That's 3 zones, so I'll increase my minimum to 3. Now that I'm here, I also want to make sure that my maximum is set to a reasonable number. Although it may be unlikely for my application to need to scale that high, it's still possible for it to go as high as 100. For my application, this is too much, so let's lower that to 30. It takes the application on my virtual machine 2 minutes to be ready, so I'll set the cooldown period to 120 seconds. That's pretty long, so I'm going to enable scaling controls in case I get any spikes when my group is scaling down. In this case, my instance group won't scale down by more than 10 VMs from the peak size as observed over the prior 10 minutes. I'm going to save these settings for now before I change one more thing. The VM type specified in the template is an E2 standard 2, but that's got more memory than I need. So let's see how I can replace that with an E2 high CPU 2 instead. Rather than clicking edit on my instance group, I can instead go up here to update VMs. Up top here, it says the current size of my instance group and the name of the template I use to create the instances in it. Here, under new template, I could add a second template and roll that out to only a certain percentage of my instance group. This is one way to do A/B testing or deploy a canary of my application. In this case, I want to replace my only template with a different one that I created for this demonstration. With one template specified, my target size is 100% of my instance group. Down here under Update Configuration, I can specify how I'd like the template to be rolled out. By selecting Automatic, the Managed Instance Group will proactively tear down or replace each of my instance group's instances created with the old template. Here, where it says Temporary Additional Instances, I can specify how many machines beyond the recommended number can be provisioned to make this transition possible. This makes it possible to maintain the recommended number of VMs while still tearing down and recreating them. Down here at the bottom is an update summary that recaps the configuration I set for this update. Once I'm finished, I can kick this update off using the equivalent command line or REST API calls. Otherwise, I can just click Update VMs here. The autoscaling offered with managed instance groups is very flexible. The cooldown period and scaling controls are a great start to setting up effective autoscaling. Also, don't forget to choose a properly sized VM on your instance template. Beyond that, there's much more you can learn from the documentation to make sure that your autoscaling is working for you efficiently, effectively, and affordably. To learn more, check out this link for more on autoscaling, and check out the link in the description for another demo on autoscaling. Thanks for watching.